Welcome back. Now let us look at non-adiabatic processes. Let us say that we have a system and I don't say that the boundary is adiabatic. So it will do some work W and it may have some other interaction other than W. We consider the following. You can write the state space as PV or Yx. Let us say that we have an initial state 1 and a final state 2. And let us say that a general process, not necessarily adiabatic. This is our process 1 to 2. It could be quasi-static, it need not be quasi-static. I don't qualify the process in any way except that it is for our given system and starts from this initial state 1 and ends at this final state 2. Then let us consider an adiabatic process. Although I have shown it quasi-static, need not be quasi-static. But let us execute an adiabatic process from 1 to 2 and let this be the representation, some adiabatic process. Now in the process 1 to 2, which is any general process, any process, let the work done be W12. In the process 1 AD2, which is an adiabatic process, let the work done be W12 adiabatic. Because one is an adiabatic process and another is a non-adiabatic process, we can say that in general the two work interactions will not be equal. Now this inequality, or not necessarily an equality, allows us to define the heat interaction, which we will now do. We will now define the heat interaction Q. We define the heat interaction Q as the difference between the actual work done in a process and the adiabatic work done by some adiabatic process from the same initial state to the same final state as the initial process. So this is the definition in our formulation, the Carathéodory's formulation of thermodynamics. Again notice that we have defined it. This is the heat interaction for the given process 1, 2. Notice that we have defined it as W12 minus W12 adiabatic, and we have taken the difference this way just as a matter of convention. We could have taken it as W12 adiabatic minus W12, but then the signs in the final form, which we will soon see, would be different. Now we proceed from here. We notice that this minus W12 adiabatic, this part, we have already defined it as delta E12. So using definition of delta E, which is minus W12 adiabatic, we can now write Q12 is W12 plus delta E12. This form or its general form, which is without that 1, 2, if we assume that everything pertains to the same process, same initial state, same final state and path, then we can write Q equals W plus delta E, which happens to be the final form of the first law. And since we are looking only at a closed system, we should note that this is the format of the first law for closed systems. Thank you.